In this section, we'll be looking at the importance of calibration and the potential applications for infrared spectroscopy. Now, calibration is also an important process for infrared spectrophotometers, just like it was for UV visible spectrophotometers. Now, just to note that you do not need to memorize this calibration protocol. This is just to help explain why calibration is important. You do not need to memorize the protocol, as you could look it up in the British Pharmacopoeia if you needed to. Now, infrared spectrophotometers need to be regularly calibrated to check they are functioning correctly and also to ensure compliance with the specifications within the British Pharmacopoeia. Now, as you'll hopefully remember, calibration is an important process in ensuring reproducibility of results across different laboratories with different pieces of equipment. And it is therefore important to ensure that all spectrophotometers can be calibrated or validated in the same way. Now, the British Pharmacopoeia states that a thin film of polystyrene should be used. So polystyrene is a polymer. We have what the polymer looks like up here. Now, this gives a characteristic infrared spectrum, which you can see at the bottom right hand side of the screen. Now, there are key absorption bands which are checked, so normally at 1601 and 1028, and they're checked to the position of those bands are checked to ensure that they are coming up in the correct position, so at the correct wave number. Now, the degree of resolution, so the ability of the machine to tell the difference between different peaks, is also checked by looking at the maximum at 2851 and the minimum at 2870, which is just here. So the spectrophotometer needs to be able to distinguish between this peak and this trough. And a valley of over or better than 18% transmittance is required. Now, by following this process and checking the spectrophotometer against a new standard, or a known standard, you can ensure that it is functioning correctly and will give the expected results. Now, infrared spectroscopy is a robust and very rapid technique. It really is very good for the qualitative analysis of drugs in different formulations, so you can easily tell whether you've got the correct functional groups present, as long as there is no interference from excipients within the preparation. Now, it can also be used to determine drug or formulation quality in an automated way. Now, infrared spectroscopy, like UV visible absorption spectroscopy, is highly amenable to automation, and that means that it's found a home in the pharmaceutical industry during drug production, checking that the batches of pharmaceuticals that are produced are up to standard and don't contain unanticipated ingredients or don't contain impurities. It's a very rapid way of telling if your synthesis has worked if you're trying to convert one functional group to another. So, for example, if you're trying to tell the difference between a carboxylic acid and an amide, this will completely change the infrared spectrum that you get, and it can also help tell you how complete this reaction has been. Now, one other key important thing to note about infrared spectroscopy is it's used as a key identity check for drugs within the British Pharmacopoeia. And this is because it is a rapid and robust method. Also, like UV visible absorption spectroscopy, infrared spectroscopy doesn't require extensive training to be able to use the technique correctly. And so it's straightforward to train an operative to check drugs, to check that they have the correct identity. So in summary, some of the positives about infrared spectroscopy are that it's, again, relatively inexpensive, like UV visible absorption spectroscopy. An infrared spectrometer is a little more expensive, but not massively so. And it can be used not just on solids and liquids, but it can also be used to analyse gases as well. Now, it's amenable to automation, and therefore it's incorporated into a lot of production pipelines throughout the world. And it provides us with some structural information about the molecule, so it tells us which functional groups are present. Now, the limitations of the technique are that it doesn't provide comprehensive structural data. So it only tells us about the functional groups which are present. It doesn't tell us what the structure of the molecule is. Now, just like with UV visible absorption spectroscopy, analysis of complex mixtures is not viable with infrared spectroscopy. And this is because you would get multiple absorption peaks on top of each other from all of the components within the mixture. Now, another downside to infrared spectroscopy is when it's not being used in an automated way, sample preparation can be time-consuming. However, newer machines now are focusing far more on the ATR technique for sample preparation, and this has really sped up the use of infrared spectroscopy, and it makes preparing samples much quicker, as you can drop them straight on to the ATR unit, which is often made from diamond. So sample preparation can be time consuming, but we can get around this. Now, from this part of the course, you should be able to either put I can or I can write down in front of all of the following statements. So you should be able to explain what information infrared spectroscopy gives. You should know the 3 key regions of the infrared spectrum and which functional groups will give absorbances in each region. You should be able to explain what causes bonds to vibrate at a given frequency and a given intensity. You should be able to interpret the infrared spectrum of simple small molecules and be able to predict the vibrational frequency of functional groups in a molecule that you haven't seen before. Now, you should also be able to explain how to prepare a sample for infrared analysis and explain why calibration is important. Now, if you would like to do some additional reading on this subject, you can read pages 113 to 127 of Pharmaceutical Analysis by D.G. Watson. Now, this gives you some more background information on infrared spectroscopy and highlights some of its uses within pharmaceutical sciences.